This is a buoyancy problem. So this is like the example I showed you in class. I've got a beaker that's holding some water, and I dip this thing in the water, right? And so what happens is this scale reads lighter because some of the water is pushing back up with the buoyant force, right? But then the reaction to that is because the water pushes up on the block, then the block also pushes down on the water, and it makes this scale read more. So this scale is going to get lower, and this scale is going to get higher, both by the same amount, right? So what does the hanging scale read? So to figure this out, we just need to figure out what the buoyant force is, right? So the force of the scale is going to equal the weight of the block minus the buoyant force, right? Because if you think about drawing a free body diagram for that block, there's Fg pulling down, there's the scale pulling up, and there's a buoyant force pulling up also. So the scale is going to be the difference between that one and that one, right? So this one minus that will leave me with the scale. So I just need to figure out the buoyant force, right? And buoyant force is density times volume times g. Okay, so how can I get that? Well, density, this is water, right? So the density is going to be 1,000 because the density of water is 1,000 kilograms per cubic meter. I need to get volume, right? Because G is 9.8. So G is 9.8. If I can figure out what the volume is, I could solve for that. Okay, what do I have that relates to volume here? Well, I know the alloy has a density, right? So I know density is mass divided by volume. And I know this alloy has a density of minus 2,700, right? So this number, in my case, is 2,700. And I know the mass of the alloy is 3 kilograms, right? So the block has a density of 2,700 and the mass is 3. So if I do some algebra here, I can solve for V. And once I know V, I can take V and plug that in up here, right? So I can get V from doing this. I can plug it in there, and then I can get the buoyant force, right? And once you know the buoyant force, you can come down here and take the weight. So mine is 3, right? 3 times 9.8. So mine is going to be 3 times 9.8 to get the weight. My buoyant force will go here, and I can subtract and get the force of the spring scale, right? That's what I'm trying to figure out. Not too bad. Okay, second part. What's the lower scale read? Okay, so in this one, basically the lower scale supports everything minus the scale, right? What this is pulling up, if this scale wasn't there, everything in here would be supported by that lower scale, right? So really I just need to tack everything together and then subtract out whatever answer I got for the force from the scale, or the spring scale up here, right, for number 1. So the total weight is going to equal, well, let's do it this way. mg for the water, right? Mass of water times g. It's going to equal the mass of the beaker times g, so mg for the beaker. And, well, I should be adding these, right? So let's make this look a little better. So the total weight is going to be the mass of the water times g plus the mass of the beaker times g plus, what else is there? There's the mass of the water, there's the mass of the beaker, the mass of the alloy, that 3 kilogram thing. So the mass of the alloy times g. If I tack all those things together, add them up, right? Then I'm going to subtract my answer from the first part. This number right here, I'm going to subtract that, and that'll give me the total weight, right? Because this block, this scale has to hold everything up except for what that scale is supporting.